Yes, very good morning to all the students. Today we concentrate on the problems based on the chopper. So before we do any problem, we should know the simple difference between time ratio control and current limit control. So first, we take the simple 2 marks question. What is the basic difference between time ratio control and current limit control? So using the choppers, we control the speed of the motor. The very first point is, if I'm using the converters, by changing the firing angle, we control the speed of the motor. If I'm using the chopper, by changing the duty cycle or duty ratio, we can control the speed of the motor. So first, what is this time ratio control? Time ratio control, we are having the duty ratio, which is T on by T. Here it is represented by K. Okay, generally we can also use the del. So time ratio control depends on the frequency. So variable frequency system or constant frequency system. And what is current limit control? In current limit control, we change the speed of the motor based upon the value of the current, the minimum value of the current and maximum value of the current. So this is what mentioned here actually. Current value varies between maximum and minimum. This method DC converter to turn on and off. So current limit control technique says that we can control the speed of the motor by controlling the value of the current from minimum value to maximum value. Okay. Whereas time ratio control depends on the variable frequency and constant frequency. So now let us look into the different stages of time ratio control. So they ask for 2 marks question, this difference you can mention. But now let us see in depth of this time ratio control. Let's move to the next slide. So if you see, the time ratio control is divided into constant frequency and variable frequency system. So what are these graphs actually? The input voltage will be constant, and in choppers we convert fixed DC voltage to variable DC voltage. So when you convert fixed DC to variable DC voltage, you are going to obtain the pulse signals. So what is constant frequency system? In the sense, we all know the formula for the frequency. Frequency is equal to 1 by T, time period. So here the T is nothing but the total time period. And what is the formula for T? T is the combination of T on plus T off, when the chopper is on and when the chopper is off. So constant frequency says that you can change the value of time period, but the frequency has to be constant. You can see it. The T on and T off values are changed, but the frequency, overall frequency is constant. If you see here, T on is small and T off width is high. Here T on width is high and T off width is small, but overall time period is constant. So simple words, constant frequency control technique involves change in the time period, whereas variable frequency control technique involves change in the frequency. How to confirm the frequency is changing? Here we say T on and T off. This is the time period. Okay. But if you see the next example, the time period value has been decreased. Therefore, when time period changes, the frequency starts to change. Here we can show here the maximum time period, here the minimum time period. So what are the different techniques to control the speed of the motor using the choppers? One is by changing the time period or maintaining frequency constant. Other technique is by changing the frequency. One simple question I am asking while we are doing the resonance experiment I mentioned. I want to send one electromagnetic signal to the long distance. What should be the frequency? Frequency should be high or frequency should be low? Anyone tell me? I want to send the signal from one cell phone to another cell phone for long distance communication. The frequency of that signal should be high or low? Anyone, come on. You can unmute and you can tell me. The frequency should be low or high. In order to send the signal from one place to another place for long distance, the signal should be very much high. Okay, right. That is, in our motors also, if I want to run the motor with high speed, what should be the frequency? Anyone tell me? Frequency should be low or high. Induction motor is present. I want to rotate the frequency, I want to rotate the motor with high speed. So frequency should be high. So when you change the frequency, the speed of the motor also starts to change. So what is this 2 marks question? Current limit control and time ratio control. In time ratio control, we can keep the frequency constant and we can change the frequency value and thereby controlling the speed of the motor. And remember this formula, duty ratio is T on by T. Okay, time taken to turn on the chopper which it is conducting. Right. So what is current limit control? Current limit control says that the speed of the motor can be controlled within the values of the current from minimum to maximum. So we focus on this time ratio control and problems also based on time ratio control. So first, straightforward, we move to the problems. All students, you please be ready with your calci right now for the problems. Yeah. So first problem we are taking. Slide is visible, all of you. Please confirm. Anyone? The slide. Yes. Voice chat lo పెట్టండి.
Yes, sir.
Okay, slide is visible. That's good. Now, first problem, you can be ready with your calci. So similar problems only we are going to expect in the examination. Now, a chopper circuit is operating on TRC, that is time ratio control. Just now we have discussed. In time ratio control, we change the value of frequency or we can keep the value of frequency. Okay, so that's why we are having this one. A chopper circuit is operating on time ratio control at a frequency of 2 kilohertz. You can ask one question, sir. DC supply frequency is how much? Anyone tell me? What is the frequency of DC current? Any student? What is the frequency of DC current? DC current frequency is how much? 0. Okay, but in choppers we convert fixed DC to variable DC. When you say variable DC, you are having the frequency. Okay, a chopper circuit operating on TRC at a frequency of 2 kilohertz on 460 volt supply. If the load voltage, now you can see, we have to decide whether it is step down chopper or step up chopper. Anyone tell me what is this chopper? Input voltage is 460, output voltage, load voltage is 350. Tell me it is step down or step up? It is step down chopper. Calculate the conduction period, means T on. Okay, so write the given quantities: input voltage, output voltage, frequency. As I mentioned, the time period T is equal to 1 by F, all the problems, and T value you are going to get the 1 by 2 kilohertz, 0.5 milliseconds. Okay, that is the time taken for the chopper to turn on and how much time the chopper will be on and off. The total time period is how much? 0.5 milliseconds. Now remember, all of you, step down chopper we have done the derivation. Anyone tell me what is the expression for step down chopper? Output voltage equal to del into input voltage. Del, in the slide it is taken K, okay, or delta. Output voltage equal to delta into input voltage. All of you are understanding, right? So step down chopper formula is output voltage. In this problem, they have given output voltage as VDC. Output voltage equal to input voltage into del. What is del? Duty cycle or duty ratio, which is T on by T. So here we have substituted the formula. VDC is equal to T on by T into input voltage. So what is T on? We have to calculate. So we know the value of VDC and we know the value of output voltage, the input voltage, and we know the value of T. If you directly substitute, you are going to get the value. So in choppers, problems will be mostly on calculation of the time period and the current. So this is the first basic problem. Is it fine, all of you? All students, the problems will be very much important. Please be accurate to listen. Right. Shall I move to the next problem now? Anyone?
Sir.
Okay, right. Right, we are moving to the next problem now. Okay, at the just in the middle, all of you listen now. I will just name the roll numbers. They have to give the answer for the questions. Okay, be ready. So second problem, if you see, input voltage to the step up chopper. They already mentioned step up chopper. So what is the formula for step up chopper? Anyone tell me? V naught equal to Vi, that is input voltage, into 1 by 1 minus del. This derivation also we have seen in the slide we have done earlier. V naught is equal to input voltage into del by 1 minus del, where what is del here? Del is equal to T on by T. So that formula, if you see, output voltage, which is V naught or VDC, V naught equal to input voltage into 1 by 1 minus del. But what is del? T on by T. So here they have substituted T on by T, and after LCM we are going to get this expression. So step up chopper means immediately you have to use this formula. Step down chopper means output voltage equal to del into input voltage, and step up chopper output voltage equal to input voltage into 1 by 1 minus del, and in the place of del you must write T on by T, then you are going to get this expression. So what is saying, input to step up chopper is 200, okay, input voltage. Output required is 600, so output voltage is 600. So 600 equal to 200 into the conducting time. Conducting time of thyristor means T on. Only the T on. How many microseconds here? 200 microseconds. The conducting time of thyristor is 200 microseconds. Here we say T on. Calculate or compute frequency. So what is the formula for the frequency? 1 by T. Okay, first we will see. So we have substituted and we got the T value here. Okay, using the formula. T on they have given in the problem, but T we don't know. What is the formula for T? T is equal to T on plus T on. So we continue the problem with the next slide. Now, frequency F is equal to 1 by T. As we got the T, you can substitute here, and then the second case of the problem. So what they are asking in the problem, frequency we have calculated. After T is equal to F is equal to 1 by T. If the pulse width is off, in the waveforms you have seen pulse width, okay, T on plus T off. If the pulse width is off for constant frequency, find the new output voltage. You can see pulse width is off means T on. On condition is divided by 2. So then we are going to get the new time period and new output voltage with the same formula. Output voltage equal to input voltage into T by T on. So which is nothing but the 300 volts. Only the substitution using the formula. Okay. Two formulas you have to remember. Step down chopper, what is the formula, anyone? Output voltage equal to del into input voltage. Step down chopper. Step up chopper, what is the formula? Output voltage equal to input voltage into 1 by 1 minus del, which can also be written as T by 1 minus T on. Anyone tell me step up down chopper? We have done the derivation. Step up down chopper output voltage is equal to input voltage into del by 1 minus del, where del is equal to T on by T. Okay, now we move to the next problem. Right. If the screen is not visible, I'll maximize the screen. Anyone can easily question this one. Come on. A DC chopper, okay, a DC chopper has a resistive load of 20 ohms and input voltage Vs is equal to 220 volts. So resistive load now, input voltage is 220. When the chopper is on, its voltage drop. So when the voltage drop is given, we have to have the modification in the formula. Chopping frequency F is equal to 10 kilohertz. Duty cycle is given. Okay. Already I mentioned. Now you see, calculate the average output voltage. What is the formula now? How to decide whether it is step down or step up? So first, In the question, they have not mentioned step down and step up. We don't know the average output voltage. So first, basically go for the step down chopper formula. So what is the step down chopper formula? Output voltage equal to del into input voltage. Okay. So first write the given quantities. Yes, we have written D. They have taken in the problem D or delta or del or K. It is nothing but duty ratio or duty cycle, which is the ratio of T on by T. Okay. So T on and T values will be given in the problem. So what is the duty cycle given in the problem? 80%. So 80 by 100, 0.80. In this problem, they have given voltage drop also, which is 1.5. So what is our average output voltage? V naught equal to or VDC equal to input voltage into del. Okay, step down chopper. V naught equal to input voltage into del. But in this problem, along with input voltage, they have given the voltage drop across the chopper. Therefore, what is the total voltage difference of two voltages? So 220 minus 1.5, as 1.5 is the drop. So if you just substitute this one, as duty cycle is given directly 0.80, VDC is equal to 0.80 into this particular value. So you are going to get the 174. So what is the explanation here? A DC chopper has a resistor load. Okay, it is chopper is controlling the electric heater or the bulb brightness, and input voltage is 220, and chopper is on, that is T on. Okay, and voltage drop is 1.5 with the chopping frequency F is equal to 1 by 10 kilohertz, and duty cycle is 80%. Calculate the average output voltage. Okay, and chopper on time. So T on, after this expression, we can even get the expression for the T on. Chopper on time is T on. So what is the formula for del or D? Del is equal to T on by T. We already know T. T is equal to 1 by F. And chopper on time T on is equal to del into T. Just substitution of the formula. Okay. So we just move to the next problem. All of you simultaneously have to calculate, you have to see in a DC chopper average load current. So when we say the word average current value, another name is DC current. So in a DC chopper, the average current or load current, okay, or IDC we can say, is 30 amperes. Chopping frequency F is equal to 250 hertz. Supply voltage is 110 volts. Calculate the on and off periods of the chopper. That means in this problem, they're asking T on and T off. Okay, if the load resistance is 2 ohms. So IDC, the output current is how much? 30 amperes. Frequency, voltage, and this value is given. Already I mentioned. Now they are asking the current. Okay, and if both voltages are not given in the problem, you can assume the formula of the step down chopper. So what is the formula for step down chopper? Output voltage equal to input voltage into del, the duty cycle, duty ratio. But what is the current formula? Current equal to voltage by resistor. Yes, sir. So IDC, output current equal to output voltage by resistor. And what is the output voltage now? Output voltage equal to input voltage into duty cycle. V naught equal to Vi into del or D. So now using this one, IDC equal to dV by R, and delta or duty ratio equal to IDC into R by V, which you are going to get the 0.545. You can ask one question once again, sir, what is this duty cycle? If I am using the converters, we are supposed to vary the firing angle in order to control the speed of the motor, in order to control the power. If I am using the choppers, we are not having the firing angle. Based upon this T on and T off, we are going to have the duty cycle. By changing the duty cycle value, we can control the speed of the motor. So always duty cycle value is less than 1 only. Okay. Now, so we have calculated the duty cycle, but they are asking to calculate the on and off periods of the chopper. So chopper on period, that is T on. Again, formula is the same. T on is equal to del into T or D into T. T on, which is equal to 2.18 milliseconds, and T off. Okay, T off is what here? So we already know T is equal to T on plus T off. T is equal to T on plus T off. T off is equal to T minus T on. Okay. T off is equal to T minus T on. Already we have calculated the T. So we are going to obtain the T off. Just substitution of the values. So now I'll give you one problem. If it is done, we will move to the last problem. These problems are quite sufficient. Right. So I'm expecting the problem from your side. Now, this one I'll maximize because it is not visible. So all the students, now you do this problem. A step-up chopper as an input voltage. So what is input VI? Step-up chopper input voltage VI is equal to 150 volts. Output voltage is 450. So it is nothing but step-up chopper. So what is the formula for step-up chopper? Roll number 18, 18. Roll number 18, please give the answer. What is the formula for step-up chopper? Roll number 14. Step-up chopper, what is the formula? Anyone? Step-up chopper. V0 is equal
V into T by 1 minus TR.
Very good, very good. So output voltage V0 equal to input voltage into 1 by 1 minus del, or we can substitute the del as T on by T. You can get this expression V0 is equal to input voltage into T by 1 minus T on. Okay, T by T minus T on. This is T by T minus T on. Okay. So what they are asking, output input voltage 150, output voltage 450, thyristor T on is 150. They are asking calculate the frequency. So we know the frequency formula F is equal to 1 by T, and total time period is equal to T on plus T off. So input voltage, output voltage, and T on we know from the problem. So first we have to calculate the T, total time. So what is a chopper, step up chopper? Output voltage equal to input voltage into 1 by 1 minus del, and the del T on by T, if you substitute, you will get this expression T by T minus T on. So after substitution, you will get the total time period. Okay. So total time period means again F is equal to 1 by T, 4.44 kilohertz. And the operation is constant after having the pulse width. Okay. So now what they are asking, frequency we have done here, the frequency. Output will needed. Given that the thyristor is conducted, up to this point the problem is finished. Okay, frequency. But here one extra additional value we have taken. What new output one condition are operating at constant frequency. If the pulse width is off, again having the pulse width off is extra question here. Okay, so when pulse width is off, the T on should be taken by 2 because only off time period. So T on is taken by 2. Once again, the frequency and time period value changes. It is 150 here. T, you can substitute, and you are going to get the expression. So Vs into T is how much? 150, and 150 minus T on. So only T on value starts to change here. You can see here T on is 150. As the pulse width is off, on time period is also of 75. You are going to get. So you can substitute. This is the expression. So chopper problems mainly for the BTech students, it will be based on the T on and T off. So today our focus was the problems, right? So let us go back. So one explanation which is tough, we will take that one, which we are supposed to finish. I think class C chopper, twice we have taken, but today we'll finish that explanation perfectly. And then we see the syllabus. This is 2-quadrant chopper. So today we'll see the syllabus, and mostly Monday or Tuesday we will have the internal. Okay, as per the JNTU, they have given the schedule from 7th to 20. We have to keep the internal. Right. So all students be ready this one. So already 4 quadrant chopper, what is the main advantage means 4 quadrant means what? Making a machine to act as motor and to act as generator, and making the motor to rotate in forward direction and backward direction, making the generator to operate in forward as well as the backward direction is simply a 4 quadrant. A machine can be operated as the motor and the generator, and that machine can also act as in forward direction as well as backward direction, which is nothing but the 4 quadrant operation. So choppers can make one particular machine to operate in 4 quadrants. This quadrants word is the explanation and behavior of the motor. That's why we explain the behavior of the motor by taking into 4 quadrants. Okay. So where we see this 4 quadrant example, when electric train is starting, when electric train is moving at rated speed, when electric train is about to stop, and when electric train is about to move in opposite direction. So 4 different conditions, behavior of electric train can be explained in 4 quadrant. Understood all of you? So when electric train is starting, so I'll show with the graph here, because this topic is what the future of every student. So what is 4 quadrant operation? First I'm concentrating on this graph. Okay, in the examination also you have to show thoroughly at least 4 quadrant diagram you have to draw. Okay, if you are not mentioning this one also, it doesn't matter. Why we are having this 4 quadrant? The behavior of a machine means which can be acted as motor and generator. The behavior of machine can be explained in 4 quadrants. So what is that behavior? For example, the machine which is used in the electric train, if the electric train is under starting condition, the machine acts as the motor. It takes maximum power from the input to the load. So now we say the machine is acting in the forward direction. It is acting as exactly the motor. It is rotating in forward direction. If the electric train is moving in backward direction, then it is called reverse motoring. Then the machine is operated under 3rd quadrant, where current is negative and voltage is negative, exactly opposite to the 1st quadrant. That means if electric train is moving in forward direction, the electric train is operating under quadrant 1. If the electric train is moving in backward direction, reverse direction, it is operating in 3rd quadrant. If the electric train is about to stop, under stopping condition, what we can do? The machine can be operated as generator, and that power is transferred from load to the source. So now the machine is operated as generator. It can be operated in 4th quadrant if the power is transferred to from load to the source, where voltage is negative but current is positive. And if the machine again it is acting as generator, then it can also be expressed in the 2nd quadrant. So these 2nd and 4th are generating operation, 1st and 3rd are motoring operation. So if you see this explanation, we have taken first part. So what happens up to case 1 we have taken, okay? We have taken twice. So number of times we will take this circuit, because if in the examination it gets, you can show what is your stuff. Okay, 4 quadrant operation of the chopper. So first I'm just moving to the case 2 from where we start. This is the case 2. Case 2 says that chopper 3 and chopper 2 are turned on. Chopper 3 and chopper 2 are turned on, and chopper 1 and chopper 4 are off. Now what is the direction of the current? From Vs plus to chopper 3 to motor, and from motor to inductor to chopper 2 to V minus. So what is the case 3? Case 3, CH3 and CH4 are on. CH3 and CH2 are on with the help of firing pulse. Direction of current flows from Vs plus to CH3 to motor to inductor to CH2, and from CH2 to V minus. So you can see this animation here. Only these 2 choppers are on. Direction of the current. Now the motor is rotating in which direction? Reverse direction. So this 3rd quadrant operation. So I want to bring the electric train in backward direction. So the current should flow to the motor in reverse direction. Initially it was flowing from CH1 to CH4. Now from CH3 to CH2. Okay, during this process, inductor energizes and motor rotates, accelerates in backward direction. Motor accelerates and rotates in backward direction, okay, and develops the kinetic energy. Okay, then what will happen? After certain period of time, inductor de-energizes and the de-energized current where it will flow. You can see here. Now motor and inductor are energizing. Now you can see inductor is energizing this animation. Okay, inductor is storing the energy in reverse direction. Now inductor has to release that energy after certain period of time. Inductor. So this is the quadrant 3 what we have discussed. Chopper 3 and chopper 2 are on. Now we are supposed inductor has to release the energy. So chopper 3 will be off. So chopper 3, just move to this one. Still animation is showing inductor is energizing and motor is rotating. Now chopper 3 is off, case 2. When chopper 3 is turned off, now inductor starts to de-energize, releases the stored energy. That energy is transferred to the CH2, and from CH2 to again it has to come back to the inductor. So from D4 to the motor to the inductor. Understood? So after certain period of time, inductor de-energizes, de-energizing current flows from L plus. This will be L plus to CH2, CH2 to D4, D4 to motor, and from motor to inductor. So next, in case 2 only, if the back EMF of the motor is greater than the supply voltage, then this motor acts as the generator. Now you can see reverse generating braking mode. When you apply the brakes, braking to the electric vehicle, the motor will act as the generator. When it will act, when you are applying the braking condition, automatically the back EMF of the motor will be greater than the supply voltage. Now the machine acts as the generator. The same words what we have discussed for the case 1. So what will happen? You can see it is acting as generator. Okay, so it generates electricity, and first it will energize the inductor. You can see from generator to CH4, CH4 to D2, D2 to the inductor. Once again, inductor is energizing because of the generator in opposite direction. So you can write here from generator to CH4, CH4 to D2, D2 to the inductor. And next, what is the final thing? Generator has to send back the power to the source. How it is possible? Now you can see. Now after this one, now you can see all the students. Yes, CH4 is off and the generator is generating the power. Its back EMF voltage greater than input voltage. That energy has to be transferred back to the source. Now you can see from the generator to the diode D3, and from diode D3 where it has to go, it will flow through the source, and from source to the D2, from D2 it comes back to the motor. You can see. So when this motor is acting as generator, energy is fed back to the source. So its back EMF voltage is greater than input voltage from the generator G plus to D3, D3 to source, from source to D2, and from D2 to the inductor and the generator G minus. Okay. So this is what the complete explanation of this 4 quadrant operation. For number of times you have to study 2 quadrant and 4 quadrant. Only the current equation we have to show. With this one. Now we'll check this syllabus here. Syllabus copy. Okay, first let us see one question paper. As I mentioned, you can see from choppers compare time ratio control and current limit control. Today we have taken working of SCR. Okay. So let us see from choppers which question they are asking. Yes, one problem. Okay, 220 volts, the same thing. Range of the duty cycle. But you see what they are asking, direct the question. Morgan's chopper and Jones chopper, which you have taken, which are very much important. Okay, right. Let me take to the new share. now we move to the syllabus. So first unit we have done, second unit, both units material I have sent. You can see, but more than the material, what we are discussing online, that online explanation class will be easy. You have to make the notes. You can find which one is easy, you can go for that. Now see all of you, choppers. The latest name is switched mode power supply, SMPS, switched mode power supply. So introduction, elementary chopper is a step down chopper only, okay, basics chopper, duty ratio, average inductor, average capacitor current is written expression. So what is the first topic? Buck converter or step down chopper. So circuit analysis waveforms in the animation you have seen, duty ratio T on by T. So chopper means duty ratio. By changing the duty ratio, we control the output voltage. Next chopper is boost chopper, step up chopper. Formula also we know, V naught equal to input voltage into 1 by 1 minus del, and the expressions, okay, the derivation what we have done. Next chopper is buck boost, which is nothing but the step up down chopper. Okay, step up down chopper also we have done the derivation, energy stored equal to energy released. What is the expression for step up down chopper? Output voltage equal to input voltage into del by 1 minus del, del by 1 minus del. So, but extra what we have studied from this unit beyond the syllabus is Jones chopper, Morgan's chopper, and class A, class B, class C, and class D choppers, and class E. So, which are not mentioned in the syllabus, but they'll ask in the examination. So, I'll take the attendance first here. Right, any question, anyone? So Monday might be internal will be there. First I will send the model paper and check that one. Then we go for the online thing. So any question is there? Monday it is okay, internal, all of you. Monday power electronics mid one. Okay, nobody is responding. That means we'll confirm it on Monday.